You open your Cambridge IGCSE Additional Math 0606 exam paper, and bam, that clock starts ticking. You've done the revision, right? Memorized all the formulas, but then you hit those geometric progression questions, and suddenly the path to the right answer isn't just a quick calculation. It's literally a multi-stage minefield. Today's explainer is all about surviving that minefield. We're skipping the fluff and focusing purely on the high-stakes reality of securing top marks for the condition of convergence, where the absolute value of R is less than 1. This topic shows up in literally every single exam series. And look, just knowing the math, it's actually not enough to secure your grade if you don't know exactly how the examiner is scoring your paper.
Okay, let's dive right into this with a 1-minute rescue. On the left side of your screen, you're looking at a pretty classic flawed student answer. The final mathematical value might actually be close, maybe even correct, but look at those gaping holes in the working. It just jumps straight from the initial formula to the conclusion. Now check out the right side. This right here is an improved top band answer. It systematically shows the extraction of data, setting up the inequality, and every step of that algebraic manipulation. The difference between these two answers, it's not just about neatness. It is a massive grade boundary risk. The student on the left is honestly just giving their marks away. Because here is the brutal reality. Missing method marks means losing the grade. It is an absolute confidence shock when you get those results back, because standard rote revision totally fails to prepare you for this. You might have known that the absolute value of R has to be less than 1, sure. But under intense exam pressure, if you skip documenting your process, the examiner literally cannot legally award you those points. You aren't just being tested on the final destination. You are graded entirely on the map you draw to get there.
Section 1. Core Principles of Convergence. So to stop bleeding these marks, we've got to establish the exact theoretical foundation examiners are actively hunting for when they scan your paper. Which really begs a specific question. Why do students find multi-stage analysis and method marks so incredibly hard for this topic? Well, it's because the Cambridge syllabus dictates that top-performing students have to show a connected conceptual understanding. You can't just treat these as isolated number-crunching exercises. No, you often have to pull knowledge from totally different areas of the syllabus and apply them to completely unfamiliar contexts. The core mathematical principle we're dealing with here is the convergence of a geometric progression. For the sum to infinity to actually exist, like for the progression to converge rather than just blowing up into some infinitely massive number, the absolute value of the common ratio, R, must be less than 1. The whole theoretical architecture of this concept rests on these precise definitions and causal relationships, and principal examiner reports constantly point this out. Candidates who explicitly reference this condition and actually show how it restricts the possible values of R achieve significantly higher marks. It's a real game changer.
Now, in just a moment, I'm going to show you a massive examiner clue that totally flips how you approach the answer. It's basically a secret hidden right in the principal examiner reports. But before we reveal that, you really need to understand the operational framework that makes this clue so obvious. Getting this down will fundamentally change how you write out your solutions.
Section 2, the 5-step answer framework. Let's get into it.
Now, what's really interesting about this slide is that it introduces a master procedural framework that removes all the guesswork. It makes solving these complex convergence problems completely systematic and predictable. Here is the standardized sequence you absolutely must follow. Step 1, read and deconstruct the question. You've got to extract that relevant data carefully. Step 2, select your analytical framework and method. Step 3, execute and actually show your steps using clear notation. Step 4, verify your accuracy. And finally, Step 5, present that final answer with the correct terminology. Look, data interpretation skills are absolutely critical at every single one of these stages. If you try to just skip from Step 1 straight to Step 5, you are walking blindly into a trap.
And this brilliantly illustrates the difference between how average students and top-tier candidates think. On the left, we've got superficial breadth, basically just trying to do a little bit of everything without actually proving any of it. But on the right, we have analytical depth. The Cambridge assessment framework aggressively prioritizes logical, structured reasoning over those superficial answers. Your cognitive domains of knowledge, application, and analysis, they all need to be firing together. A deep analytical proof will outscore a broad, unproven guess every single time. Section 3. Top examiner warnings revealed. Okay, let's escalate the stakes a bit and see what happens when we apply this framework to complex scenarios. Here is that crucial examiner alert I promised you earlier. This is the method mark strategy clue that literally saves failing grades. Examiners explicitly state this. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Seriously, think about that for a second. If you make a tiny arithmetic error in step 4, but you clearly showed your substitution and algebraic setup back in step 3, the examiner is still going to reward your logical process. Those method marks are your absolute ultimate safety net. So, the crucial point here is knowing exactly where students constantly trip up. Pulling straight from the principal examiner reports, here are the top 3 mistakes. Number 1, using the wrong approach for the context, like applying a standard sum formula when a sum to infinity doesn't even exist. Number 2, forgetting to check format and presentation. This means sloppy notation that the examiners simply can't read. And number 3, providing generic answers that aren't specific to the actual context or parameters given in the question. I want you to just look at this giant 0 for a second. This is a visual pattern interrupt for a very good reason. This 0 represents the exact number of marks you'll get for a 6-mark question if you just write down the correct final answer with absolutely 0 working. No joke, it doesn't matter if you did it perfectly in your head or on some scrap paper that you threw away. No working shown literally equals 0 method marks. It's brutal, but it's the truth.
Section 4. Mastering critical analysis.
Snagging those final top-tier marks takes way more than just raw calculation. It requires comparative analysis and really evaluating your evidence. Top-scoring candidates in the 0606 exam consistently demonstrate evaluative thinking. But what does that actually mean? Well, it means they question assumptions. For instance, double-checking if the common ratio actually falls between -1 and +1 before blindly calculating a sum to infinity. It means they consider different perspectives, maybe identifying limitations or alternative interpretations. And most importantly, they justify their decisions with cold, hard mathematical evidence. You aren't just solving a math problem, you're building a watertight mathematical argument.
And that argument? It has to be presented flawlessly. Examiners are strictly looking for conventions. We're talking proper headings, correct mathematical terminology, appropriate formats, and incredibly clear annotation. If you define a variable, write down what it is. If you're applying the convergence condition, explicitly write down that the absolute value of r is less than 1 before you start plugging in your numbers. This level of professional presentation is exactly what unlocks those final evaluation marks on the grading scheme.
All right, so we've deconstructed the theory, the framework, and those critical examiner warnings. You know exactly what they want to see. But this leaves a massive unresolved problem hanging over your head. How on earth do you actually apply this comprehensive 5-step framework in the exam hall before the clock runs out?
Because let's be real, knowing the strategy is only half the battle. If you can't execute it under intense timing pressure, the framework just won't save you. That is exactly why the full rescue kit isn't optional. It continues in the next part of this explainer series. You absolutely must follow through to the next segment if you want to ensure your exam survival.
In our follow-up explainer, we're tackling the exact problem of that ticking clock. We'll be implementing the mathematics, additional 0606, timed answer writing system. I'm going to show you how to compress this entire 5-step framework into lightning-fast automatic habits that let you extract data, write flawless method steps, and totally beat the exam timer without sacrificing a single method mark. You're going to want to jump into that next explainer right now to solve this timing pressure problem immediately. Seriously, do not walk into that exam hall without mastering your timing. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Jump into the next explainer right now and ask yourself, what would it actually feel like to confidently write down your final answer, knowing you've mathematically proven every single step to the examiner without the clock running out?